All right, today we're going to be solving negative x squared plus 2x plus 4 by use of the quadratic formula. Let's get our quadratic formula down first. So this is easy to look up, but it's also easy to remember the song. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's plug in our values. In this case, our b value is 2, so it's going to be negative 2 plus or minus square root of 2 squared minus 4 times a is negative 1 times c, which is 4, okay, all over 2 times negative 1. Now, we simplify this to negative 2 plus or minus the square root of 2 squared is 4, minus 4 times negative 1 times 4. So negative 4 times negative 1 is 4, times 4 is 16. 4 plus 16, right? Plus, because we have the two negatives. And we end up with 20, root 20, all over negative 2. Now we've got to change this root 20 into something we can work with, and there's an easy way to do that, because we have to remember that every square root can be represented as two square roots which multiply to that square root, right? So we could do root 5, root 4. And remember, when we're simplifying radicals like this, we're trying to build perfect squares. So I know that 4 is a perfect square, and that's why I chose it. If 9 went into 20, we could use that too. It doesn't. 16 went into 20, we could use that. You get the idea, but in this case, 4 is our only option. So then that becomes 2 root 5, and that's what we're going to write instead of root 20 from now on. Negative 2 plus or minus 2 root 5 over negative 2. Simplifies to 1 plus or minus negative root 5. And this is going to give us our two answers now. So it's 1 plus root 5 and 1 minus root 5. That's our two x-intercepts. And so how would we graph this? Just quickly, because I think students do get confused on this more often than maybe even some of them like to admit. Dealing with square roots and trying to plot them on a graph, that transition can be tough. So the way I like to do it is find the closest perfect square. So in our case, we know that root 4 equals 2. So root 5 is going to be just a little bit more. It's going to be something like 2.2, right? So then that lets us get the numerical value of these expressions. 1 plus 2.2 puts us at around 3.2. 1 minus 2.2 puts us at negative 1.2. And then we have the next part is easy. We have our c value, which gives us our y-intercept of 4. And we know, of course, that it's a negative graph, so it's an upside down u, right? Our a value is negative. So it'll look something like this. And if we did it right, the axis of symmetry should be on the 1, because they're both points are going to be equidistant from 1, right? 1 plus something and 1 minus something. So you go exactly root 5 in either direction. And our graph should look kind of like that. All right?